Hello all, myself is AJAYPRADEEP, Assistant Professor from the Department of Computer Science and Engineering, Madarapalli Institute of Technology and Science, Madarapalli. So welcome you all to the lecture on Introduction to Cognitive Computing. So this is the synopsis of the presentation, what we are going to see. And we are going to discuss about what is cognitive computing, what is the need for the cognitive computing, how cognitive computing works, so what is the prime focus and the objective we are moving towards, what are the examples of cognitive computing, and applications and EndNote. So this is the workflow what we are going to see in this lecture. Initially, we are going to discuss about what is cognitive computing. So cognitive computing is a technology and application oriented based on artificial intelligence. So this is the definition. Cognitive technologies are the products of the field of artificial intelligence. So they are able to perform tasks that only humans used to be able to. So this clearly explains cognitive computing is a task. Cognitive computing is an application which can be performed only what humans can do. That is, in other words, we can say that cognitive computing is a type of artificial intelligence that simulates human thought process, that involves machines that can learn, reason, and understand language in a way that is similar to how humans can do. This explains that a cognitive machine, a cognitive computer can learn, it can reason, it can understand the language in a way that is which is similar to a human can do. So it is not a different one, or it is not kind of a robot, but it can understand, it can learn, and it can reason, and it can able to manipulate what a human can do, and in a way that what and how a human can do. So this is the definition of cognitive computing. So in broader description, cognitive computing systems are able to process large amount of data and identify patterns and relationships that would be difficult or impossible for humans to detect. So something which is different what we saw from the previous definition. Here they are saying that we can able to process large amount of data and identify patterns and relationships that would be difficult or impossible for humans to detect. Cognitive computers understand the content in a way how a human does, but it can process large amount of data sets and unimaginary amount of data sets which could be processed by human. That is, it can process extraordinary amount of data, but it understands the data in a way how human does, but it can process the data in an unimaginary way than a human can do. So coming to a smaller example, for instance, you could see calculation of a problem. So you could calculate a problem with a pen and paper. You could calculate a problem with the help of a calculator. You could calculate a problem with the help of a programming code. You could calculate a problem with the example of a computer. So likewise, we can have n number of ideologies and methodologies to solve a problem. So this is for a smaller problem. When it comes to a very larger task, so if the instance data set is of 100 numbers, we can process that with help of a paper or pen or a calculator or a computer or a programming code. If the data set instances of 1 lakh instances or 10 lakh instances or 50 lakh instances, so we are going for a very massive code and massive data set. So the data set will be very massive, and the extraordinary amount of data set can be processed with help of cognitive computers. So this is how a cognitive computing can be made available for a real-time application or a real-time problem. So this technology is used in a wide variety of applications, including healthcare, finance, and manufacturing. So now we know that we are moving from traditional methodologies to technologies which can be embedded with artificial intelligence. And under artificial intelligence, we are applying certain methodologies like machine learning, deep learning, neural networking, neural computing, etc. So this is for processing large amount of data sets. So the data sets can be processed by traditional methods such as statistical analysis. But the same thing when it comes to the computational methodology of artificial intelligence, and in addition, it is deployed by machine learning or deep learning or neural networking. We can process the same thing in a smarter and better way with very less effort. So if we are framing a code, and based on the code, we can change the data set. So by changing the data set, we can process the other data set. So likewise, it is a one-time investment of preparing a code and gathering the requirements. So we can change the data set and we can process the same thing for a different application. So likewise, so cognitive computing is applied in very broader applications such as healthcare, finance, and manufacturing, etc. Okay, here is how the cognitive computing works. So, cognitive systems are typically based on artificial neural networks, which are mathematical models that are inspired by the human brain. So, uh, in continuation to what I said, so it depends on mathematical models. So, previously I said that so we can process a problem with the help of statistical analysis. We have mean, median, mode, etc. Certain probabilistic models and statistical models which can be used to solve a problem. In the same way, the same problem can be solved with the help of the computation, advanced computation techniques such as machine learning or deep learning or artificial networks, artificial neural networks. So in this way, we could say that cognitive systems are based on artificial neural networks, which are basically mathematical models. And this is the important consider that it is based on the inspiration from the human brain. So this is the most important thing. And these networks are able to learn from data and improve their performance over time. So like a machine learning model, so which can learn from the data which is fed to the model, and it can improve the performance over time. So if you are feeding n number of data, based on the data which is fed, the performance will be improved over the time. So likewise, the cognitive models work, and the cognitive computing systems are also used. Various cognitive computing systems use a variety of other techniques such as natural language processing, machine learning to understand and interact with the world around them. So you could have heard about the term called natural language processing, which is also an application of deep learning. So where we process the languages, certain languages, not certain languages, we are applying natural language processing to a very different set of languages, and a broader a classification of the speech and the vocabulary is made in certain way. So text processing can also be made. So in such a way, cognitive computing works in various applications and various fields, which can be extended to certain other fields also. And cognitive computing can be considered as the technological game changer. So it understands the language, recognizes objects, text, face, and the scenes, and also recognizes the voice and interacts with the humans and other machines. So what it implies is, so when we use language processing, for example, a person is traveling to a different state. So for example, a person belongs to Andhra Pradesh. He travels to Arunachal Pradesh or Gujarat or Delhi or Jammu and Kashmir. So which are all having the base language as Hindi. So he knows only Telugu. He doesn't know Hindi in a sense. So with the help of cognitive computing or of artificial intelligence, he or she can be able to understand what other people talks. So just based on the voice recognition. So when we transfer the language into the application what we are developing, so he or she can understand what the other people talks. So likewise, based on cognitive computing, we can process languages, we can recognize the objects, we can recognize this, face, text, and other things which is around us. This is one thing. And next is the human quality that is not possessed by machines is the emotional and spiritual connection. So we discuss certain things about how the machines will work in a way human work. So machine can understand the content in a way a human can understand. So machine can process certain things which a human can understand. But the thing is, a human quality, humans have certain qualities, that is the emotional qualities and the spiritual connections. So these things are these qualities won't be processed by the machines. So they may really understand the statement but don't know to understand the emotion underlying it. So when you search certain thing, so today is my birthday, a machine can understand today is your birthday, but emotionally it can't react. So, oh, today is your birthday, fine, so glad, I'm glad that today is your birthday, happy birthday. It won't say that. It can understand today is your birthday, that's all, but it can't express the emotion which is been delivered. So this qualities would help machines understand human more accurately, like Siri or Alexa assistants. So we have certain chatbots and assistants like Siri or Alexa. So these help to understand the human interaction or human emotions somewhat accurately. These assistants somewhat lack to understand the social and cultural context of the questions. So these personal assistants, such as Siri or Alexa, are not true example of cognitive computing. So these chatbots are the ones which help us to do our day-to-day task, but they are not the perfect or true example of cognitive computing. The answer as per the pre-programmed responses purely fed into the systems, but soon the time will come when we talk to these assistants and get a thoughtful response. Example, chatbots. So we can get the answers. So the answers are pre-programmed to that. So based on the pre-programmed answers, we are getting the outputs. This is what this implies to. Next, we are going to see how analysis can be made using cognitive computing. So cognitive computing can analyze vast quantity of structured as well as unstructured data and can make recommendations. So we can process both the structured data as well as the unstructured data. So the data which is in the form of structured data or in form of unstructured data, both can be analyzed and which can be programmed. So the analysis can be made to both structured and unstructured data. So it can do this for any field such as healthcare, finance, law, education, etc. So it can be applied to n number of applications. So very vast set of applications. We can say that it can be applied or extended to n number of applications, not only limited to healthcare, finance, law, and education. It can be applied to n number of applications. For example, if we want to analyze all the information in the patient's records, which is under healthcare, journal articles, which is under education, diagnostic tools, which is under healthcare, best proven practices, which may be related to finance or healthcare or law, etc., anything, and suggest the doctor's treatment decisions. So which can be limited to healthcare. Likewise, any application. So the broader applications may be healthcare, finance, etc. And based on the broader applications, we can narrow down to some smaller applications or smaller domains in which we can apply cognitive computing very effectively and efficiently. And it is not that it will overpower the rule of the doctor. So one thing we need to understand is, so we are moving towards cognitive computing and we are going to apply cognitive computing for healthcare. So in this case, whether healthcare application which is applied with cognitive computing will overrule the doctor or it will overpower the doctor, it is not the way. The doctor is still the master. It will help the doctor to make better decision by analyzing the humongous amount of information available that not human can reasonably process and retain such a huge amount of information. So for this, we can take an instance example. So we are stuck up with the code. So we are processing some code. Say we are processing some Python code or C programming code. So we are stuck up with an error. So immediately what we will do? So we will go to a search agent such as Google or applications such as ChatGPT, and we will copy and paste the error what we are getting. So immediately we will get responses. So immediately we are getting the responses means only when we are landing upon a issue or a error, we are going for a help towards an agent such as Google or ChatGPT. Likewise, when a doctor is struck up with a certain situation, he haven't made or he haven't met or whether he would have met with a certain situation earlier, but he needs some more input on that. So immediately uh, he can't be able to get such an information. So he may get from other doctors, etc. But immediately with the help of such cognitive computing, he may able to replicate the data over the back volume, that is the past years or past back volume data. So immediately with the help of cognitive computing, the doctor can able to analyze the case effectively and efficiently, and he can able to process it. So this is how cognitive computing will help the person who is applying it or who is using it. So this is a very important thing, that the technology which we are applying won't overpower us, but it will help the person who is applying that. The focus and objective what we are planning in cognitive computing. So the idea is to make the computer think more like humans and help us to make accurate decisions that will maximize the chances of success and bring an era that it will expand our capabilities and knowledge. So again, what we saw with the example of a doctor, the idea is to make the computer think more like humans. So the computer will think more like humans and it will help us to make accurate decisions and maximize the chance of success. So when we make certain decision, so there won't be a probability that we will land up in failure. The probability is that for sure we will be getting the chance of success. And based on this, we can acquire more and we can acquire more knowledge and we can expand our capabilities. So this is the prime objective of cognitive computing. And in other words, the prime objective is to develop computers and systems that are capable of tackling complex problems that usually require human cognition. So people say a computer can solve, a machine can solve the process very smarter and better than human. But indeed, the machine acquires knowledge from the human. So based on what human inputs only, machine are acquiring knowledge. The same thing is expressed here. The prime objective of cognitive computing is to develop computer systems that are capable of tackling complex problems that usually require human cognition. So this is the focus and objective why we are going for cognitive computing. And here we are going to see about certain examples of cognitive computing. The first what we are going to see is the game of chess. One example of cognitive computing is the game of chess. In chess, a player must use their cognitive abilities to analyze the board presentation, analyze the board position, evaluate their options, and make a move that will improve their chances of winning. So, the game of chess involves the expression of human cognitive abilities such as analyzing what is the current board position, how we can evaluate the options, what the next move we can make, and how we can move forward, how we can process the game further, and what are the way which we can apply for getting the chances of win, that is the success. So a cognitive computing system can be programmed to play chess by using a variety of techniques such as artificial neural networks and machine learning. So the same cognitive computing can be helped for training a computer to play chess. So based on the artificial neural networks and machine learning, we can train the computer to play chess. So this is what they are implying here, and these techniques allow the systems to learn from its mistakes and improve its performance over time. So thing is, so when we apply cognitive computing initially to train the computer to play chess, for the first instance it won't win. For the second instance it won't win. So based on the mistakes, so it will learn over time, and after some successive time, so the machine will be capable of winning in the all the instances. So this is how cognitive computing works in the game of chess. And next we are going to see a very interesting example, self-driving cars. So cognitive computing systems are also being used to develop self-driving cars. Self-driving cars must be able to navigate the road safely, efficiently, and they must be able to make decisions in real time. So you may imagine the example what we saw previously, that is the playing the game of chess. So playing the game of chess won't harm anyone, but this one is a very relatively interesting example, that is a self-driving cars in which it involves the real-time action in the road. So self-driving car means, so in other words we can say as the car without a driver. So in this case we can say a relative example of metro trains. So in overseas countries there are metro trains, so which has no pilot, that is the no driver trains, so where the trains drive based on the instance which is been trained. Likewise, self-driving cars should be able to navigate on the roads very safely and efficiently. It should not harm others, it should not make any unnecessary accidents, etc. So in such a case, cognitive computing systems can be used to help self-driving cars to identify objects on the road. This is the first task. So when training the system with the help of cognitive computing, so it should be able to identify the objects on the road, it should be able to identify the track, the movement of other vehicles, and make the decisions about when to accelerate, when to apply brake, and when to turn. So these are all the aspects in how cognitive computing will be applied in order to train the self-driving cars. And the corresponding applications of finance and healthcare is dealt in here, and we are going to see how we are applying healthcare and cognitive computing is used in wide variety of applications including healthcare, finance, education, etc. So which we saw previously, we are going to see the in-depth explanation of the same. In healthcare, systems powered by cognitive computing may aid in diagnosing diseases, developing new treatments, and managing patients' care. So this is a very interesting application, the healthcare. So modern healthcare systems apply there we don't have any kind of pen or paper interaction. So even a very small instance of treatment includes the data which is entered in the computer. So even a very hospital located in a very remote place have the computation capabilities, and we have computation all over the healthcare domain. So in such a case, healthcare can be applied for diagnosing diseases. So certain medical diseases involves usage of computers. So certain diseases such as mentally retarded diseases such as autism, certain mentally retarded diseases such as dyslexia and therapisia, etc. These kind of diseases involves human interaction as well as the machine interaction with the person who is affected. So when we apply such kind of mechanisms, that is the computational mechanisms in healthcare, we can be able to attain the success rate very effectively. So there are many cases which has been dealt in the medical literature. Using the computational capabilities, we can arrive at giving a very good treatment for the patients who is affected, and also managing the patient's records over time. So imagine some 15 to 20 years back, gathering the records of patients. So there will be a very large warehouse or storeroom for managing the patient records. Everything will be made in a file. So we'll be taking writing or taking printout. Printout won't be possible in certain cases, but we'll be just writing the content, and we'll be filing that, and everything will be stored in a warehouse. But now, so everything is stored in cloud. So it is very easy to retrieve a patient's record even 20 years back or 25 years back. Just within seconds, we can arrive at the solution by searching with the patient's name. So this is how healthcare is being dealt with the help of computation. Next is finance. So cognitive computing systems can detect fraud, manage risk, and help make investment decisions. For example, a bank may use cognitive computing system to analyze financial data and identify potential investment opportunities. So like stock markets and mutual funds, nowadays people are applying machine learning and deep learning algorithms in order to identify the patterns and trends, and based on that they are applying they are investing on the stock market or mutual funds. So likewise, cognitive computing can be applied in the domain of finance. And next is the manufacturing technology. Under manufacturing technology, cognitive systems can be used to optimize the production process, predict maintenance needs, and manage inventory. For example, an aviation company may use a cognitive computing system to monitor the health of jet engines, and it can able to predict when they need to be serviced. So likewise, the man intervention, that is human intervention, is much reduced in such cases. Next is the power and energy, which is a very important domain. Smart power is the new intelligent future. The oil and gas industry faces huge cost pressure to find, produce, and distribute crude oil and its byproducts. So, based on the crude oil price, the price of the fuel is decided in certain countries. So, in our country, India, also we are deciding the cost of fuel based on the crude oil cost. So likewise, when applying cognitive computing kind of technologies to the domain of power and energy, we can arrive at a very smart decision making in order to go further. So energy firms take various critical decisions where huge capital is involved, like which site to explore, allocation of resources, and quantity of production. So this is a very important field and a domain, so which needs to be focused much for going forward, going further for a very developed nation such as India. So while planning itself, we can apply cognitive computing in order to have a very effective and efficient solution. Next is cyber security. This is a very interesting and important domain where people are not aware of, or in other words, we can say that which needs to be given more importance. Cyber security, cognitive algorithms provides end-to-end cyber security platforms, and detects, accesses, researches, and remediate the threats. So it will help to prevent cyber attacks. So it may be cognitive hacking. This may make customers less vulnerable to the manipulation, as well as provide a technical solution to detect any misleading data or disinformation. So imagine a very large IT firm or IT company. So there they are having very confidential files which should not be disclosed to others, say the other competitors or other IT firms or companies which are competitors to them. So they will be having a very high-end security platform in order to prevent their data or a mishap of the data. So in order to prevent the mishap of the data, they will be having very high-end security platforms. In spite of this security, if there is any breach, the data would be leaked or the data will be compromised and it will be uh, shared or it will be discussed to the others. So in such a case, in order to avoid that, so certain kind of cognitive computing applications can be applied in the domain of cybersecurity in order to predict and avoid or manipulate such kind of attacks. So this is related to cybersecurity. And next we are going to see about the educational domain. So cognitive computing is going to change the way education industry has been working. It has already started bringing a few changes, like how we are working towards the education. So 50% will be of the lecture delivered in the class and 50% will be lecture delivered in the online. So certain kind of forums, online tools apply cognitive computing for having a very much interaction with the task or domain what we are learning or what we are discussing about, and based on the interaction through certain tools, the student will be able to understand and identify what sort of concentration he or she should make towards the topic and how he can understand the topic in a very effective and efficient way. So a cognitive assistant can provide personal tutorials to students, guide them through the coursework and help them to understand certain critical concepts at their own pace. So this is what I said. Certain tools help students in order to understand the content in a very effective and efficient way. For example, a student is lagging in linear algebra. So in such a situation, so certain cognitive assistant like the a tool which is being delivered or deployed by an organization, a university or a college, will help the student what in which way he or she is lagging in the topic, and it will help them to improve themselves in their own pace. So this is about education. So it also guides students in selecting the courses depending upon their interest. For example, a student who is completing his plus 2 or PU, so he or she is thinking should what he or she should do next. For example, some may be relatively having interest in engineering, some may be relatively having interest in commerce, some may have in visual technology. So anything, he or she at the age of 17 or 18 won't be having much capability of deciding what to do next. So in certain cases, based on applying cognitive technologies, a student can be supported in order to select what task or what course he or she can select. So cognitive computing will not help only students but also help the teachers, the supporting staffs and administrative staffs for delivering better service, preparing student reports, preparing notes and other feedback data. So this is how cognitive systems will help in the field of education. And the topic of banking and finance. So cognition in banking industry will help to improve operational efficiency, customer engagement and experience, and also in order to grow and improve its revenues. So cognitive banking will completely reshape the banking and financial institutions on the following three listed dimensions. The first is deeper contextual engagement, next is new analytical insights, and third is enterprise transformation. So this is how banking and finance can be improved with the help of cognitive computing. The system will intelligently understand the personality of the customer based on the content available online authored by the customer. For example, the system will understand how the customer is using the bank's e-banking site or mobile application. So based on the interaction or based on the usage, the cognitive system will suggest personalized ad experiences or personalized product experiences. So it will be supporting the customer to select the correct product based on his or her own choice. Based on the interaction, the system will suggest or support the customer. And next is man versus machine or man plus machine. So this is something which explains how cognition is used to um, this is something which explains how cognition works, that is a man versus machine or man plus machine. So cognitive systems learn and reason from the interactions with human beings and their experiences with the environment. This captures people's imagination, but it also sets up man versus machine. But that is not intended at all. So far what we have discussed, so we may think, people may generally think that, so if we apply cognitive computing, so manpower will go off. So for example, wherever we go, like banking or finance or education, healthcare, etc., we are applying computers. So then what is the need for human? So manpower will be cut off. So this is the general perception everyone will have, but it is not the perfect way, or this is not the correct thing. That is what it is intended here. So various studies show that between man and machine, it will beat either man or machine. That is because of various capabilities of both the things have, which a man have or machine have. Humans stand unique with capabilities like intuition, compassion, design, value the judgments, the common sense, and on the other hand, the machine have the capabilities of having immense computational capabilities like the capability to fast check the facts, deep learning, large scale math, and to reason that helps to get into the discovery. So this point clearly explains that, this content clearly explains that how human has certain capabilities and how a machine has certain capabilities. So the thing is, machine can do certain things in a very smarter way, human can do certain things in a smarter way, but both are, but without the support of each other, the cognitive computing can't be applied. This is what we are intending here. And as a note, with the advancement in the technology, machines and humans have learned infinite ways to collaborate. So one such way is cognitive computing. So it is expected that more capabilities based on cognitive computing will evolve over time. So it requires certain technological advancements as well as physical advancement in order to apply cognitive computing in certain fields. The main aim of cognitive computing is to harness the data and insights to deliver a better experience, values, and individual engagement. So the applicability is much easier and integration with various other applications is much easier, which makes cognitive computing a success centric one. So we can apply this easier and we can integrate this with certain applications, various applications very easier. So by this we can say that cognitive computing will be a success centric one in the future. These are the references, and thank you all.